All right, Herr Thonagel, a short introduction.
Yes, please. Is it you do the introduction, right?
Okay, thank you. So, well, welcome. My name is Dirk Roggenbuck. I'm the CEO of the Medipan and GA Generic Assays, GmbHs, and I'm a member of the diagnostic network in our region. And what I would like today is to give a presentation on the advances in autoimmune disease diagnostics. Well, what I'm trying to do is more or less to give you an example for a biomarker and new innovative test systems. But before I start with this topic, I would like to touch upon the health capital cluster. This is a cluster that is supported by the Bundesländer Brandenburg and Berlin. Well, and here this cluster comprises more than 21,000 businesses in the healthcare sector. Approximately 300,000 employees work in these businesses, and the revenue of these enterprises is about 27 billion. And I think these are remarkable figures which underline the potential of the healthcare industry in our Berlin-Brandenburg area. And we are really thankful for the support by our governments for this healthcare cluster. In particular, I would like to mention here the colleagues from the Office for External Economic Affairs of the Ministry for Economic Affairs, Labor and Energy of the Strait of Brandenburg. Our network, which is illustrated here on this slide, enjoys a very good cooperation and support by this office. Well, a few words about our network. It comprises more than 70 members, not just diagnostic manufacturers, but also device manufacturers, suppliers, and other interested parties. Well, and I think one of the most important advantages of our network is that we can provide solutions for the development of in vitro diagnostics. I think this is something very attractive for interested parties. We can, by combining all the expertises of our members, give you tailored, a tailored project in order to address your needs. Well, and that brings me to my topic today. As a matter of fact, I tried, or my task was to give you an overview on the latest developments in the field of autoimmune diagnostics. I would like to do that here with one example, which has been carried out, or the development of this project was done in the Berlin-Brandenburg area. Well, and it touches upon a very interesting syndrome in the field of autoimmunity. This is the antiphospholipid syndrome, and here the differentiation of this rheumatic syndrome from infectious diseases. Well, for the serological diagnosis of the antiphospholipid syndrome, antiphospholipid antibodies are recommended. And here I need to go a little bit back to the past, well, in the, let's say, 60s and 70s, the antiphospholipid syndrome was sort of a false positive syphilis diagnostics. And well, what we learned is that for syphilis diagnostics, the first assay that was introduced was just the detection of anti-cardiolipin antibodies. Well, and this is illustrated here on the left-hand side, the interaction of specific antibodies that are raised during the infection by with Treponema pallidum, this interaction with cardiolipin, which is diphosphatidylglycerol. Well, and in the 90s, it was disclosed that with regard to autoimmune clinical phenomena, beta-2 glycoprotein 1 is the main autoantigenic target that we have to consider with regard to the detection of specific antibodies for the antiphospholipid syndrome. Well, and here, this is the point where I would like to highlight the actual, question that we can put forward. Well, just let's take the example of the SARS coronavirus 2 infection. Here, we also discuss the occurrence of antiphospholipid antibodies. We see the same clinical characteristics and symptoms in patients infected by SARS coronavirus 2. These are coagulation problems, thrombotic events. This is very similar to the antiphospholipid syndrome, and I would like to come back to that to these interrelated processes later. Well, with regard to the cutting edge technology development, which has been accomplished in our area, this was a line immunoassay. And the line immunoassay gives you the opportunity in a multiplex format to detect several antiphospholipid antibodies in one sample, which is illustrated here. You see the different phospholipid targets that are presented by this assay, and well, not just the phospholipid targets, but cofactors such as the beta-2 glycoprotein 1, which I already introduced too. Well, and in practice, it looks like this here. You see that by the means of this line immunoassay, you can detect IgG as well as IgM antibodies, which play a pivotal role for the serological diagnosis of the antiphospholipid syndrome. Well, and when we compare these two patients, which are illustrated here with the red rectangles, you know, we see on the left hand one patient which obviously has an antiphospholipid antibody interacting with beta-2 glycoprotein 1, the cofactor, whereas on the right hand side, you know, we see a patient that has several antiphospholipid antibodies. Well, and this is an interesting phenomenon and needs to be discussed further, because here with this new line immunoassay, we have a better reaction environment that gives us the opportunity to specifically detect antiphospholipid antibodies. Well, and I would like to compare here the different methods available for the detection of antiphospholipid antibodies. I will start with the ELISA technique, where we have a flat, solid phase, you know, and when we talk about phospholipids, we need to take into account that these phospholipids are amphipathic molecules consisting of a hydrophilic as well as of a hydrophobic moiety. Well, and in the ELISA, during the process of insolubilization or during the process of coating, well, at the end of the day, we see a random absorption of such amphipathic molecules, and at the end of the day, and this is the point which I would like to make, the huge hydrophobic moiety is exposed to the reaction environment and gives a hell of problems, as a matter of fact, for, with regard to unspecific interaction with components of the sample. Well, it's different when we talk about line immunoassays, because here we employ a hydrophobic membrane that has pores. And so when we look at the immobilization process, we see an oriented immobilization of the amphipathic molecules, such as, for instance, the phospholipids, and that gives us a completely unique reaction environment for the detection of antiphospholipid antibodies. And that is summarized here on this slide. So I have three variants of antiphospholipid antibodies, 3 types that we can detect. The first type, these are antibodies that interact directly with the phospholipids coated on the surface of the membrane. The second type, which from my point of view is the most important one, that involves the cofactors which are present in the serum of the patient. And the third type, this is the direct interaction with cofactors immobilized on the surface. Well, and that brings me to this slide, which more or less describes the second type of antibodies, antiphospholipid antibodies that require the involvement of cofactors for specific binding. And this is and this is supported by many experts in the field. This is the main type of specific antibodies that we find in patients suffering from this particular autoimmune syndrome, the antiphospholipid syndrome, because here, and this is seen in the center of the cartoon, we have a conformational change when the cofactor present in the serum of the patient, of the sample that is under investigation interacts with the phospholipids. That leads to a conformational change, and by doing so, beta-2-glycoprotein 1 forms a layer on this phospholipid surface, and that creates a very specific reaction environment for the ascertainment of these specific antiphospholipid antibodies. Well, you know, it's always one thing to develop such a new reaction environment. The other thing is to prove it by an appropriate clinical study. And this is what I would like to touch upon very shortly here. This is the clinical study that we conducted together with opinion leaders, in particular here from Italy, in order to prove our hypothesis and to prove the robustness as well as the efficacy of our assay. And the interesting point is that we not just included patients suffering from the antiphospholipid syndrome, but also controls, and here in particular asymptomatic individuals that demonstrated antiphospholipid antibodies in other assays. Well, this is a very difficult slide. I would like to guide you through what we can summarize from this slide is that the new method, the line immunoassay, demonstrates a significant reduction of antiphospholipid antibody positivity in the control group compared with the APS patient cohort, which is not the case with ELISA. Well, this is illustrated here for the quantitative detection of these antibodies in the line immunoassay here for the anticardiolipin IgG detection. There is a significant reduction of antiphospholipid, in this case anticardiolipin IgG, in the control group in contrast to the APS cohort. Well, and in ELISA, you do not see this significant reduction. Well, this is really interesting, but in order to prove this hypothesis, you know, we investigated sera which only interacted with these domains, with the lower domains of the beta-2-glycoprotein 1, whereas on the other hand, we had sera only interacting with domain 1, that means with the upper part of the molecule. And when you look at the data, and I think this is very impressive, well, in this constellation here, there is no positivity whatsoever by the line immunoassay, and that is always related to a false positivity of antiphospholipid antibodies detected by other assay techniques. Whereas when we have the constellation that is illustrated in the lower part of the table here, when we have a D1, domain 1 reactivity, we see various positive results obtained with the line immunoassay. And that, at the end of the day, supports our hypothesis and in a way confirms the advantage of this reaction environment using a line immunoassay format. We can detect the specific antibodies that bind to the domain 1 of the cofactor beta-2 glycoprotein 1, whereas other antibodies interacting with the lower domains will be not detected in such an assay, and that makes the assay very specific. Well, this is one thing, to have a high specificity and a high sensitivity. But what is most interesting here in this sense is, can we use the assay for the risk analysis or prognosis of patients? And I only would like to demonstrate here very shortly very intriguing, from my point of view, mind-blowing results. I have summarized that for you here. You can see recurrent thrombosis is highly associated with the occurrence of more than 4 antiphospholipid IgG antibodies detected by the line immunoassay. And when you look here at the risk, at the odds ratio, it is about 36. That means that patients demonstrating more than 4 antiphospholipid IgG antibodies have a 36 higher risk to develop recurrent thrombosis. And as a matter of fact, this is what we would like to have. You know, this is a nice tool, a smart tool that addresses a clinical need. We have here a new test that can not just analyze antiphospholipid antibodies for the serological diagnosis of the antiphospholipid syndrome, but also can provide data with regard to the prognosis of the disease. And I would like to highlight that again. This, of course, meets a clinical need. Well, and shortly, I would like to bridge these data with the, let's say, current topic that we are all concerned with. This is COVID-19. We all know that in critical ill patients, we see coagulation issues, thrombosis, well, and it has been just recently demonstrated that antiphospholipid antibodies, which you can detect in these critically ill patients, you know, these antiphospholipid antibodies are pathogenetic through the activation of neutrophilic extracellular traps. Well, and this is something that we can use in order to do sort of a prognosis even here in this field with these patients suffering from an infection with SARS coronavirus 2. And only shortly, you know, because the method which I presented today, which we used for the detection of these antiphospholipid antibodies, can also be used for the detection of antiganglioside antibodies. And these ganglioside antibodies, they are pathognomonic for autoimmune peripheral neuropathies, such as the Guillain-Barré syndrome. Well, and this is really interesting because we see in patients suffering from COVID-19, of course, neurological symptoms. And it seems to be that at least part of these neurological symptoms could be due to autoimmune processes. Well, and the explanation for that is molecular mimicry, because the coronavirus 2, the SARS coronavirus 2, bears on its surface sialic acid, which is also found on the surface of nerve cells, and that is then the basis for this theory. Well, and when you look at this paper here, Guillain-Barré syndrome, the first documented COVID-19 triggered autoimmune neurologic disease, I think there is much more to come, you know, with regard to the link of autoimmune diseases, in particular autoimmune peripheral neuropathies, as well as the antiphospholipid syndrome and COVID-19. Well, and with this short outlook, I would like to close my presentation. Once again, I would like to summarize, you know, that this was a development which was carried out here in our region in Berlin-Brandenburg. This was a cooperation of small businesses with research institutes. this is something that we have been able to bring to the market. It is a product that is already sold and is appreciated by opinion leaders in the field. And I think now in the context of the SARS coronavirus 2 infection, COVID-19, it offers even more opportunities for the detection of autoimmune processes in these patients, and maybe this will give us an edge in doing a sort of a risk or prognosis analysis for COVID-19 patients. Thank you for your attention. It was a very short presentation, very concise. Well, I hope I was able to get my message across to you, and I'm happy to take your questions.
Thank you very much, Professor Roggenbuck, for your very interesting insight into the autoimmune diagnostics of today. There is a question. You presented the LIA in comparison to the ELISA, and it seems to be much better. So why is still the whole industry talking about the ELISAs?
Well, thank you very much for this just question. Well, why ELISA first? I think this is for historical reasons. You know, you need to take into consideration that the antiphospholipid syndrome is a very young syndrome. You know, first reports have been published in the 80s of the last century. And well, the first classification criteria were defined in 1999 and then revised in 2006. And as a matter of fact, we do not have any diagnostic criteria available. Well, and everything started with ELISA. That was the first method that was used in order to detect antiphospholipid antibodies. And later on, we saw the development of other solid phase immunometric methods for the detection of antiphospholipid antibodies. Well, I think that the line immunoassay, that was a breakthrough in this sense. It's cutting edge technology, because here for the first time we can realize an oriented immobilization of the amphithetic molecules, which are the phospholipids. I think this is a completely new concept. I myself, I have published several reviews on that. I think the concept is now appreciated by opinion leaders in the field. Well, and with regard to the interaction of this particular, let's say, layer of orientedly immobilized phospholipids with the cofactors, that is the new thing, that is the unique characteristics of the line immunoassay, and apart from the multiplex format that the line immunoassay can provide here, I think this is one of the major advantages of this new assay technology.
And if I understand you correctly, there are like wells in this on the surface where the amphithetic molecule enters with the hydrophobic site. But what do you do in the topmost layer between the wells, so to say?
Well, this is an interesting question. Yeah, I do apologize. I did not have time today to discuss all the details of this intriguing interaction. But you are right. You know, the first principle we have to discuss here is the interaction of the hydrophobic moieties of the amphithetic molecule, the antiphospholipid, with the hydrophobic surface of the membrane. And once again, this results in the disclosure of the highly hydrophobic moiety of the phospholipid, which at the end of the day gives us a better reaction environment, a lower probability of unspecific reactivity of this particular coating procedure. Well, but then, and this is here another unique feature of this method. Usually, when you want to develop an assay for the detection of cardiolipin antibodies, for instance, what you need to do is to add the cofactor, in this case, beta-2 glycoprotein 1, to the coating solution. Well, here in this case, this assay uses the beta-2 glycoprotein 1, meaning the cofactor, which is present in the sample of the serum. So, well, from my point of view, this is a very smart example for individualized diagnostics, because we would like to detect here specific antibodies which give us information on the occurrence of the antiphospholipid syndrome in the patient. Well, and I think everybody will agree upon that it's best to use the autoantigenic target of the patient. So, well, and I think I would like to highlight this again, to have the beta-2 glycoprotein 1 of the patient, the beta-2 glycoprotein 1, which is present in the sample we are investigating, interacts here with this phospholipid layer. That leads to the conformational change of the beta-2 glycoprotein 1 and the, then the presentation and the exposure of formerly hidden cryptic epitopes. And it is these cryptic epitopes that we need for the specific detection of antiphospholipid antibodies. And that here is the advantage of the method. And well, I hope I got that message across to you. This is the reason for the high sensitivity, but also high specificity of this new method.
Just one question directly continuing there. Is this easily transferable to other diseases or indications?
Well, this is what I tried to explain during my talk, but once again, I'm very sorry for the, maybe not, for the explanation that was not sufficient in this sense. You can use any other amphipathic molecule which could act as an autoantigenic target in this new reaction environment. And the example which I gave you at the end of my talk was detection of antiganglioside antibodies. These are antibodies which are pathogenic in autoimmune peripheral neuropathies, such as the Guillain-Barré syndrome. Pathogenic antibody means that this antibody induces the damage, and here in this case on nerve cells. And by doing so, it is the reason for the occurrence of clinical symptoms in patients. Well, and that is here the point, you can take this new reaction environment, this novel reaction environment, and transfer it to the detection of antiganglioside antibodies.
Okay, thank you. I believe we have time for one or two more questions, and I have a very long question I will just read out here. On this basis, if someone has an autoimmune disease, will you be able to make a prognosis on how likely someone is to have a more severe case of corona disease than others? It is well known that it causes no symptoms at all to very severe symptoms and death, but there seems to be no indication yet who will react, how and why.
Well, thank you for this.
Dr. Roggenbuck, we have to come. You have only 1 minute.
Okay, this is a very interesting question. The only thing I can say here, yes, this is my goal. You can use the detection of antibodies in order to do a risk prognosis in COVID-19 patients. COVID-19 in its most severe form is a dysregulation of the immune system. Autoimmunity is a dysregulation too. So we have here a certain association, and this is what you can investigate by detecting autoantibodies.
Okay, thank you very much. And with this, I believe we come to the end. Do you want to say some last words, or should I jump in beforehand?
Yeah, well, I would like to thank you all for your interest, and please do not hesitate to contact me if you have further questions. I will be happy to address them.
And I can only thank you in the name of all the auditorium again for your interesting talk. Visit the booth of DiagnostikNet at medica.diagnostiknet-bb.de and also join the next talk that starts in 10 minutes about the think tank veterinary diagnostics with Dr. Stein from the Freie University of Berlin. Thank you very much.
Thank you. Bye-bye and have a good day. Stay healthy.
Thank you.
Wow.